All right, guys, today we're going to start a new chapter, chapter 6, and we are going to get an overview of conic sections. And then once we kind of get an overview of conic sections, we're going to spend the next couple of lessons talking about specific conic sections. So we're going to talk about what conic sections are, and we're going to figure out that they are just sections of a conical surface, and conical comes from a cone, right? So we're looking at a cone, and we're taking cross sections of a cone. We're going to define a circle as a locus of points. Locus just means collection, so a circle is a collection of points. We're going to learn how to graph and translate circles. We're going to find domains and ranges of relations involving circles, and then we're going to find equations of circles under various conditions. All right, so first, what is a conical surface? That is the union of all lines that connect a point that is not in a given plane to the points of a simple curve in a given plane. So again, connecting a point to a plane. Connecting a point to a plane is a conical surface. The curve in the given plane, which we call the generating curve, is a circle. Then the conical surface is called a circular cone. So we learned those in geometry. It's a 3D shape, a circular cone. So this is what it looks like, a circular cone, okay? So that is a conical surface right there. All right, the center is called the vertex, okay? And then we have the lines right there. That is the axis, okay? That's going through the vertex, and it's called the axis, okay? Then we have the elements, okay? Those are lines that go through the vertex, and they, if you notice, they make the outside part of the cone. So that's an element. It's made, a conical surface is made up of many elements, as you can see. We have it called our naps, right? That's the outside part of the conical section. Those are naps as well. Okay, so when a plane cuts across a surface or solid, the result is a section, okay, or cross section. The plane cuts across the surface at right angles to the axis. Okay, so if it's a right angle to the axis, we have a cross section. A conic section is the intersection of a plane and a right circular cone. So what we were looking at earlier, those were a circular cone, and a conic section is the intersection of that plane. Okay, a plane can intersect a cone in 7 ways. We're actually only going to study 4 of those ways. We're going to study a circle in this section, and then we're going to study parabolas, ellipses, and hyperbolas. Okay, so we're going to study those 4 intersections, but there's actually 3 more. The other 3 occur if the plane passes through the vertex, a point, a line, and 2 intersecting lines. So those are the other 3 intersections. Okay, so let's talk about a circle. The circle is the intersection of a right circular conical surface, so what we were looking at before, and it's the intersection of that and a plane that is perpendicular to the axis. So remember, the axis was that line that goes straight through the center. So it's going to be perpendicular to that, okay? The exception is that the circle will not be at the vertex, because then it would be just a point. So here's our conical surface. Remember, the axis goes straight through the center. So our circle has to be a plane perpendicular to that. So our circle would be something like this, the red line. That's the circle, right? That's the circle. So now let's get the definitions of the other intersections that we're going to learn in this chapter. There's something called the ellipse, and that's the intersection of that conical surface and a plane that is not parallel to an element of the surface, and it's not perpendicular to the axis. It intersects only one nap of the surface. Okay, so let's see what that looks like. So remember, these little things are the naps, right? And an element is a line that goes straight through the vertex. So an ellipse would be something like this, okay? So the ellipse is not a circle, but it's also not on one of the elements. A parabola is the intersection of a right circular conical surface and a plane that is parallel to an element. So what that looks like is this, right? Okay, it's parallel to an element. Parallel to an element. So that is parabola. Then we have a hyperbola, and that is the intersection of a right circular conical surface and a plane that intersects both naps, so the upper and the lower. I mean, it's not going to be at the vertex, okay? So that right there would be a hyperbola. Okay, so how do we figure out the different types of conic sections? There's 4 of them, right? So we take this general equation, ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0, where b equals 0. So basically, this number right here does not exist, okay, because b is 0, all right? If a and c, so if the number in front of x and the number in front of c are non-zero and the same number, if a and c are the same number, so the number in front of x squared and the number in front of y squared are the same, you have a circle, okay? If a and c are non-zero, they're not equal, and they have the same sign, it's an ellipse. Okay, if a or c equals 0, but not both of them, so either a equals 0 or c equals 0, okay, so one of them equals 0, you have a parabola. So parabola, that's like quadratic, so think back to your x squared, right? X squared is a parabola. Well, that's because the y squared was 0y squared. The y squared didn't appear, okay? So we're also going to learn about parabolas that are y squared as well. And those look really interesting. Okay, if a and c are non-zero and exactly one of them is negative, so one's negative and one's positive, you have a hyperbola. Okay, so where do we get conical sections? The Greeks, okay? They were cutting conical surface with a plane. The curves themselves can be considered apart from the surface on which they lie on, okay? So when we are studying conic sections, we are not going to be looking at this 3D figure anymore because it's going to be very complicated to draw that every single time. So we are going to take these conic sections and put them on the coordinate plane, okay? We're going to do that by looking at the equations. All right, so let's get the definition of circle. A circle is a locus of points. Locus just means collection, so a collection of points in a plane at a fixed distance, and we call that fixed distance a radius, from a fixed point, and we call that fixed point a center in the plane. All right, so every point on the curve, so every point on this curve here lies a distance r, which is your radius, from C, your center, okay? So every point is this distance. That distance is constant, okay? That distance is constant. All right, so the point on the curve would be your xy. That could be many different. You get to plug in x and y, right? And your center is your hk, and that's going to be constant in your equation. That's not going to change. The h and the k will not change, okay? If you remember when we studied quadratic formulas, we also had a vertex at an hk that we got from the work form. So it's very similar to a circle. The hk is a value that we can figure out to help us graph, okay? But we want to figure out where does this equation come from, okay? Well, we know that xy and hk is a distance, okay? There's a distance between those 2 points, and it's equal to r, which is a fixed number, okay? So we can use our distance formula, okay? X minus h squared, right? The difference between our x values squared plus the difference between our y values squared, and we take the square root, that's the distance formula, equals r, right? Equals r, okay? So, can manipulate that a little bit. We are going to square both sides, and we get x minus h squared plus y minus k squared equals r squared. This is what we call the working form of a circle equation, okay? So, write the equation of a circle with radius 4 and center 2, negative 1 in work form. Okay, so remember the center is hk, which means your h is 2 and your k is negative 1. And your r is 4. Okay, well, work form is x minus h squared plus y minus k squared equals r squared. So we're going to plug in our h, our k, and r. So we get x minus 2 squared plus y minus negative 1 squared equals 4 squared. So we're going to simplify that. We get x minus 2 squared plus y plus 1 squared equals 16. Okay, so you can also go backwards. If we started with this guy, our equation, and it said, what is the center? Well, we would know the center is 2, negative 1, right? 2, negative 1, the h and the k. We'd also know that our radius is 4 because the square root of 16 is 4. All right, so let's say we need to graph that circle, okay? So they gave us the center, okay, and they gave us the radius, and we put that into work form. And so now we have this equation, and now we have to graph it, okay? Actually, no, I'm sorry, this is a new equation. They give us a new equation, I'm sorry. It's x minus 2 squared plus y plus 4 squared equals 9, okay? So the first thing we want to figure out is our center. Where is the center of the circle at? Well, we know that we have an h value, and we know that we have a k value, which means our center is at 2, negative 4. So we're going to go 2, negative 4, and that's going to be the center of our circle. Okay? Now we need to figure out the radius. Well, 9 represents r squared, which means the radius is 3. So we can go 3 from the center in all directions. 1, 2, 3, 1, 2, 3, 1, 2, 3, and that is where the circle expands to. Okay, so notice that this is 3 away. 1, 2, 3, 2, 3, 1, 2, 3, 3 in all directions. Okay, so let's say we need to graph this function. Square root of 9 minus x minus 3 squared minus 1, and that's equal to f of x, which of course we know is y. Okay, so let's go ahead and write y instead of f of x. And then we're going to add plus 1 to both sides. Then we're going to square both sides. And you notice how I'm seeing y plus 1 squared equals 9 minus x minus 3 squared. I need to get this x minus 3 squared to the other side to put it into work form. So I'm going to add x minus 3 squared to both sides. Now I have y plus 1 squared plus x minus 3 squared equals 9. It's now in work form, which means that my center is at negative 1, 3, and my radius is 3. Okay, so now that I know that my center is at, center's at 3, negative 1, and my radius is 3, I can graph it. Okay, so now I go find my center, which is 3, negative 1, and I have a radius of 3, which means that it's going to be 3 in all directions. Oh, it kind of cut off. So I won't be able to graph anything down here. So just a little note here. If you are graphing a function, remember a function has to pass the vertical line test. If you draw the entire circle, it's no longer a function because it does not pass the vertical line test. So when you graph it in your calculator, it is only going to graph the upper part of the circle. It will not graph the lower part because your calculator only graphs functions. So again, you'll only see the top half of the circle. So make sure you read directions correctly. If it says graph the circle, make sure you're graphing the entire circle. If it says graph the function, you'll only be graphing the top semicircle. All right, sometimes in order to get our equation of the circle, we need to complete the square. So this is something that we learned in Algebra 2, and it's something that we learned during the first semester of Pre-Cal, and now we're going to talk about it again. So let's go over the steps. Step 1, group the x terms and group the y terms together. Okay, you're going to place the constant term on the opposite side of the equation. So again, this completing the square, these steps are specifically for completing the square to get your circle equation. So again, group your x terms, group your y terms. They're both going to be on the left-hand side, but they're just going to be grouped together. Then you're going to place all constants on the right-hand side. Okay, step 2, you're going to factor the coefficient of x squared from the terms that contain x. Step 3, take the numerical coefficient of the x term and divide it by 2. Okay, divide it by 2. Then square that answer. You add that number inside the parentheses to get a perfect square. Okay, you just can't add a number inside the parentheses. It's not legal. You have to compensate for this addition on the other side of the equation. Okay, if there's a number in front of the parentheses, you have to multiply that number you're adding by the coefficient in front of the parentheses. You're going to repeat those steps for the y terms. Okay, so you're going to complete the square twice. Complete it for the x terms and then complete it for the y terms. And step 6, you will have perfect squares, so you need to go ahead and factor those perfect squares and then simplify the other side of the equation because you should have had things added to that side. So you want one complete number on the other side. Let's get an example. We have x squared plus y squared plus 4x minus 6y equals 12. So first step, group your x and y terms together. So what we're going to have to do is that x squared and that 4x need to be next to each other, and the y squared and the minus 6y need to be together. So I'm going to rearrange that. I'm going to put parentheses around them. They are now a group. Okay, I just made groupings of them. Okay, now my next step is I need to take half, or actually my next step would be to factor out any number in front of x squared. Fortunately for us, this is a nice equation. There's no number, well, there's a 1 in front of x squared, but since there's nothing for us to factor out. Yay! So which means we can go ahead and complete the square. We're going to take half of the number in front of x, which is 4. So half of 4 is 2, and then we're going to square it. 2 squared is 4, which means we're going to add 4 inside the parentheses, add 4. But since I had to compensate for that, so since I added 4, I look, is there a number in front of the parentheses? No, that means I'm just going to add 4 to the other side as well. Now I repeat with the y values, okay? There is nothing to factor out in front of y squared, so I'm okay with that step. But now I have to take half of the number in front of y, which is negative 6. So half of negative 6 is negative 3. And then I square it. Negative 3 squared is 9. So that is the number I'm going to add inside parentheses. I'm going to add 9. Now I have to compensate for 9 on the other side. So I look, is there a number in front of the parentheses? No, there's not, which means I'm just compensating 9. So I'm just going to add 9 to the other side of the equation. All right, so I have perfect squares now, which means I can factor them. All right, I'm going to simplify the right-hand side. So 12 plus 4 plus 9 is 25. And this is a perfect square, which means it becomes x plus 2 squared. And this is a perfect square, so it becomes y minus 3 squared. And now I have an equation for a circle. I have an h and a k value, and I can get my r value. It looks like my center would be negative 2, 3, and my radius would be 5. Okay, now we get to graph it. Yay. Okay, so we're going to graph our center, which was negative 2, 3, and our radius is 5. So it's going to go 5 out. There we go. There's our circle. Find the center and the radius of this equation. So first thing we have to do, group our x terms and our y terms together, right? Group our x terms and our y terms together. When we have our x terms and our y terms together, we need to factor out the number in front of x squared. The number in front of x squared is 5, right? So 5x squared, we're going to factor out a 5, which leaves us just x squared. We have to also factor out the 5 and negative 10x squared. So negative 10 divided by 5 is negative 2. So we end up with 5x, 5 parentheses x squared minus 2x. You can always check back to make sure you did it correctly. 5 times x squared, 5x squared. 5 times negative 2x, negative 10x. So it works, all right? Also, we had to factor out the term in front of y squared, which is a 5. So 5 goes into 5y squared once, leaving us y squared. 5 goes into 30y 6 times, leaving us 6y, okay? So make sure it checks. 5 times y squared, 5y squared. 5 times 6y, 30y. So it works, okay? Now that we factored out the leading coefficients in front of the square terms, now we can complete the square. Okay, we're going to complete the square. So half of negative 2 is 1, and 1 squared is 1. So we're going to add 1. We have to compensate for that, so we have to add 1 to the both sides. But wait, don't forget, we're not just adding 1, we're adding 1 times 5. So we have to compensate a plus 5 on the other side. And over here, half of 6 is 3. 3 squared is 9. We have to compensate for that 9, but wait, we're not just compensating 9, we're compensating 9 times 5, which is 45. So we would have to add 45 to the other side. So here's our plus 5. We're compensating for the 1 times 5. And here's our plus 45. We're compensating the 9 times 5. All right, so this is where we end up with. The next thing we have to do is we have to get rid of these coefficients. So we're going to divide every term by 5. So this divided by 5 leaves us just x minus 1 squared. This term divided by 5 leaves us y plus 3 squared. And then, of course, 45 divided by 5 leaves us 9. Okay, so now we have the equation of a circle, which means that we have a vertex of 1 comma negative 3. And we also, I'm sorry, that's the center, right? The center is 1 comma negative 3. And our radius is 3. Okay, so here's a new one. Find the center, the radius, domain, and range of the circle. Okay, so first thing we want to do, group the x terms and the y terms. Okay, and once we do that, it's time to complete the square. Okay, so half of negative 2 is 1. 1 squared is 1. Make up for it on the other side. Luckily, there's not a term in front of x squared, so we don't have to worry about that. Then now the y terms, half of 6 is 3, 3 squared is 9, make up for it on the other side. There's not a coefficient in front of y squared, so we don't have to worry about factoring out that. So we're great, okay? So good so far. We go ahead and factor those perfect squares, and we go ahead and clean up the right-hand side. Negative 1 plus 1 plus 9 just leaves us 9. Now that we have the circle, let's get the answers. Our center is 1 comma negative 3. We got that from our h and our k. And then our radius is 3 because 9 represents r squared. Okay, so r squared, if we try to solve for r, we get 3. Okay, now what about domain and range? How can we figure that out? Well, let's go look at the, okay, let's look at the circle. Center at 1 comma negative 3, radius of 3. Okay, so here's our circle. Domain looks like it's coming from negative 2, right? That's your smallest x value, all the way to, what number is that? 1, 2, 3, 4, all to 4. 4 looks like the highest x number. Range looks like 0, all the way to 1, 2, 3, 4, 5, 6, negative 6 is your lowest y value. When we talk about domain and range, the domain is between -2 and 4. The range is between -6 and 0. All right, here we go. Graph the following system and shade the solution set. So we need to graph those circles, okay, shade them, and then the part where both of them are shaded is our solution, okay? So first circle, x squared plus y minus 2 squared is less than 16. You might be, well, hold up, what's our h value? Well, since our h value isn't there, that means our h value is 0, which means that the center for the yellow circle is going to be 0, 2. 0, 2 is our center for the yellow circle. And that means our radius is 4, so we're going to go out 4, and then that's the yellow circle there. Our green circle has a center at 1, 3, and radius is also 4. Okay, so there's the green circle. Okay, notice that they say less than, right? Less than means inside the circle. Less than means inside the circle, and both of them were less than, so we shaded inside the circle for both of them. The solution set is what is the intersection of those two circles, or the intersections of the shaded areas of those two circles. So it's just this middle piece right here, this middle piece right here. So that's going to be our answer for that. Your turn, 6.1, 2 through 6 evens, due in class with your notes.